And good morning, good afternoon, or good evening, whenever you're watching this. We're going to continue solving quadratic equations by factoring, and we're going to work with GCFs and difference of squares and all kinds of different factoring, group factoring. So here we go. The first thing we said was to get everything on one side so it equals 0. It is helpful to put it in descending order as well. This one on the left is already in descending order, but I can factor out something that they have in common, in this case, a 9. So I'm going to factor that out, giving me 9y squared plus 6y plus 1. And then that 9 is still there, and I have to factor into 2 parentheses. Let's see. It looks like 3y plus 1 and 3y plus 1. Pair of numbers give me 1, go at the end of each, that's the only option. Pair of numbers give me 9, 3 and 3 also, smiley face, give me 6y, you're good. All right. Now, here's the part of solving that you have to go, all right, how does this work? We know we take all of the things that are multiplied together to equal 0, that at least one of them has to equal 0. But in this case, can 9, which is one of the things multiplied, 9 parenthesis parenthesis, can 9 actually equal 0? And no, it can't. So we're going to not have 9 equal 0. And by the way, technically, if you want to get rid of 9, you could always divide both sides by 9, and you'd end up with the 2 parentheses equal 0. I'm not going to bother to do that. I'm just going to leave it and basically ignore the 9. But you could get rid of it if you chose. But if it's got a variable, don't get rid of it. All right, so I've got my 3y plus 1 equals 0. Am I going to have to solve that one? The answer is no, because it's exactly identical to this one. So, kind of a redundant statement there, exactly identical. Subtract 1 from both sides, 3y equals negative 1, and then divide both sides by 3. Y equals negative 1/3. You can always test it by going back up to the top and plugging it back in for y. All right, let's take a look on this side. We said we'd like to have everything on one side equal 0, and the other caveat here is we would like to have our expression in descending order. So 2x squared minus 72 equals 0. A little easier to work with, not required. And you will see some books that leave it the other way. They factor out a negative 2, and they, by putting a negative 2 in, they get some number minus x squared, and they can write it that way, and you can factor it that way. Difference of squares, the x just happens to be second in each parenthesis. But let's keep it this way. We factor out a 2. That gives me x squared minus 36. And again, the 2 is there, and we're going to factor this into x plus 6 and x minus 6, difference of 2 squares. Now I'm going to set each equal to 0 and solve. X plus 6 equals 0. Remember, the 2 does not have a variable, so we're not including it in what we set equal to 0. X minus 6 equals 0. Let's solve by subtracting 6 on both sides here. Or add 6 on both sides here. And there you have your answer, positive 6 or negative 6. Let's see. Here we go. You try this one. I'll give you a few minutes. You can unpause the video after you've finished. All right, assuming you have just unpaused the video, having done this, the first thing is, what is my biggest exponent term? In this case, it is the x squared term. And so I want everything on that side since the coefficient for the x squared is currently positive. So I'm going to subtract 480x and add 360 to both sides. Descending order, 160x squared minus 480x plus 360 equals 0. Now, the next step in this process is to factor out the GCF. Well, we know 10 is going to be part of the GCF, but it's probably not the biggest part. So I'm going to put a 0 down just for my own peace of mind. I believe 16 is not going to go into all of them, because it doesn't go into 36, but 4 certainly goes into all of them. So I'm going to factor out 40. See how that works out. Now 40 times 4 would be 160, 4x squared. Let's see, 4 times 12 is 48, so minus 12x plus 4 times 9 is 36, so 9. All right. Again, the 40 comes down. I could have divided by 40 to get rid of it, but I'm just going to leave it there. And inside, I believe it's going to be 2x and 2x to give me 4x squared. We're going to have a minus and a minus. 3 and 3. Let's check. Negative 6x. Negative 6x. Sure enough, that adds to negative 12x. So yes, I have the right factoring. All right, now I'm going to set equal to 0 and solve. 40 is not going to be set equal to 0. 2x minus 3 equals 0. Well, that's the exact same thing. I'm not going to write it again. I'm just going to solve this by adding 3 to both sides. 2x equals 3. And then I'll divide both sides by 2. X equals 3 over 2. That was a funny 3. 3 over 2, or 1.5. And that should be your answer. Let's check out the next problem. Word problem, or word problem type of problem. It basically says find the value of x that makes this true. Area of the square is 36 yards squared, and one side is 2x yards. So we know that the area of a square is found by taking the side squared. So 2x squared equals 36. Remember, 2x, not just the x. 2x is being squared, which really is 4x squared equals 36. Now, we would like to get all our variables, all our expressed terms on the same side, and so it equals 0, so I'm subtracting 36. 4x squared minus 36 equals 0. Now, you might have just jumped to the conclusion that, oh, that's difference of two squares, and that's great if you recognize that. But you could also factor out a GCF, which will make our work just a little bit easier. A 4 factors out, and I get x squared minus 9 inside. And we know that factors into x plus 3 and x minus 3. So I can take each of these terms, or factors, and set them equal to 0. X plus 3 equals 0. X minus 3 equals 0. And let's solve. Oops, that's for the other one. x is negative 3, x is positive 3. Well, am I going to be able to have, if I put negative 3 in here, a negative 6 yards on a side? Not going to work. So I need to use positive 3 as my answer so that one side of this would be 6 yards. And that's how you do that problem. X has to be 3, and the length of the side would have to be 6 yards. Now, I know some of you could have done that in your head, but that's not the point. All right, let's take a look at this one. This is a little bit different. In this one, you want to factor out the GCF as we have before. I believe 3 and x can be factored out. When we factor out 3x, we get x squared plus 5x minus, let's see, 14. X, two sets of parentheses, x in the beginning of each, a plus and a minus. 7 times 2 is 14, differs by 5, so 7 positive, 2 negative. Now, this is different from the previous ones where we had a term on the outside like this. This one includes a variable. If you have a variable on the outside like that, you need to make sure you set that equal to 0 as well. So 3x equals 0. X plus 7 equals 0. X minus 2 equals 0. Now I solve. If I'm trying to solve for this one, I need to get rid of that 3, divide by 3. X, well, 0 divided by anything except 0 is 0. I'm going to subtract 7 from both sides. And I'm going to add 2 to both sides. So here are my 3 answers. Now the other way that could be written is x equals 0, comma, negative 7, comma, 2. And that's a short way of writing it. All right, next problem. By the way, the main reason this gets set equal to 0 is because x could be 0, and that would cause the whole thing to equal 0, so that is one of the possible answers. Here's the next one. Now, in this case, our biggest exponent term is x to the third. That currently has a positive coefficient, so we want everything on that side. And so I'm going to subtract 4x and subtract 20 from both sides. Do not try to combine like terms if there are no like terms. Descending order, x to the third plus 5x squared minus 4x minus 20 equals 0. How many terms are we working with? 4 terms. If we're working with 4 terms, we know that that requires, or is likely to require, group factoring. So I take the first 2 terms here, pull out what they have in common, which is x squared. That leaves me with x plus 5 inside. So now I want to look at the last 2 terms, including the sign. Can I factor something out to leave me with x plus 5 inside? That's one way of thinking of it. The other way is what times this gives me the first term here, and that would be a negative 4. It works either way, the same. And when I factor out a negative 4, I get x plus 5 inside. The next step in this process of factoring with group factoring is you factor out the parenthesis, x plus 5. That leaves me with x squared minus 4 in the other parenthesis. These go in their own parenthesis when we factor out the x plus 5. Well, it turns out this is difference of two squares, so we can factor that. And now we can finally get down to solving. X plus 5 equals 0, x plus 2 equals 0, and x minus 2 equals 0. Subtract 5 from both sides. X equals negative 5. Subtract 2 from both sides, or negative 2. Add 2 to both sides, or positive 2. So those are my three possible answers: negative 5, negative 2, positive 2. Here's our last problem before we go on to what will be your homework tonight, which is in Google Classroom. This is very different from what we've seen before, and you haven't seen how to factor one like this. Let me demonstrate. When the first term is x to the fourth, the middle term has x squared, and the last term has no variable, this would be factored in this fashion: x squared, just like we did x and x when this was x squared and x to the first. We know it's going to be a minus and a minus, and 225. Let's see, 225. 25 we know goes into that. Remember, these are the same sign. We're adding the numbers. Let's see, that would be 9. Now, wait a minute. Does 9 plus 25 give you 34? It happens to. So we stumbled upon the correct setup: 25 and 9. And this is difference of squares, so is this. So x plus 5, x minus 5, this one, x plus 3, x minus 3. And now we can come up with our answers. Now, some of you already know that the answers are going to be negative 5, positive 5, negative 3, and positive 3. But for those who aren't as insightful as that, x plus 5 equals 0, x minus 5 equals 0, x plus 3 equals 0, and x minus 3 equals 0. And I'm running out of room here. Subtract 5 from both sides. X is negative 5. Add 5 to both sides. X equals 5. Subtract 3. X equals negative 3. Add 3. X equals positive 3. And we could just put one big OR for all of that. And that would be your answer. I think I'm going to replace that part with this. And let's make it a different color. All right, there's your final answer. Red or black, doesn't matter. And that's it for today. Have a good day.